this. I'm out of town.
Okay, okay.
I'm actually in New Orleans, so
Oh,
I'm,
okay. You're closer to me now.
yes, I am. Uh-huh.
Okay. So is New Orleans beautiful? Good looking
It's
good?
good. We actually just got here yesterday. We were in Pensacola, Florida for spring break.
Yeah.
So we just got, my brother lives here in New Orleans, so we just passed by to visit him.
Oh, all right. That's good.
Yeah.
That's very good. Yeah, spring break. I did not even realize it was spring break. Flew by so fast.
Yes. You guys, when you don't get, what's your kids' spring break?
Actually, they were on spring break this last week. This week.
Oh, okay.
Yeah, this one right here.
Okay.
Yeah. So how's the Pensacola weather? Was it good?
It was okay, but this storm windy thing that was going on, it
Yeah.
caused so much wind
It's
in the
getting
sea
cold.
that
Yeah.
yeah, it was windy and we couldn't do much in the beach.
Yeah. I understand. Okay. So today we are going to go ahead and continue with what we did last time. Okay, I'll go ahead and
Mhm.
share my screen here. I saw you submitted your work yesterday.
Yeah, I was submitting. See, I was in the beach all week, so
Oh yeah. Okay.
I didn't get to it
Yeah.
until yesterday.
Okay. So how do you find it? Was it in line with what you're learning? Any challenges?
So, I mean, it makes sense, but a lot of them, it's not that I can look at the question and
Yeah.
answer it from my head.
Okay.
I have to go to and put it the code in and see what it brings.
Yeah. Yeah.
So I don't know, is that the objective of the quiz, or is like to practice and see what happens, or am I supposed to already know the answer?
No, no, no. You practicing. Whatever you're doing, that's the right one. I mean, nobody knows all this.
Okay.
I
Because
can,
I was like, okay, I don't know these things. I'll just copy and paste it into, you know,
yeah,
into
that's the way you
the
learn.
what?
Yeah. I would probably do the
Okay.
same too. I mean, some of them might not be very obvious, but when you paste and when you put it in a like in a Google Colab, then you run it, then you'll be able to see what it does. Yeah. So today we are going to talk about strings as a type of data or data type. So we last time
Mm-hmm.
we spoke about uh, let me see. Of course, we talk about the primitive, which are the numbers, the floats, and how we actually use them for assigning and then do calculations. So at that point, we ended whereby we can assign like three or even more different variables to one value. You see here,
Yeah.
yeah. So if we did that, then that means A, B, and C will all have the same value, which is number three. So Python allows us to assign a single value to several variables all at the same time. Okay? And before that, we also saw how we can actually do, uh, like we can assign one value to one variable, and then we go ahead and assign another new value to the same variable. That means this four will be in the memory location number one, and then we again assign 5.5 to another memory location number one, which means 5.5 will override the location which was which was originally 4.
Mm-hmm.
Then we can assign again a string to the same memory location. Remember we said Python doesn't care, so you don't have to be explicit. it implicitly will know that this is a string, this is a float, and this is an integer, and this is here, it's going to be a list. So if we did that, we were able to come up with this particular solutions. Okay. So we say alternatively, we can also just go ahead and even do something like this. So all the variables here, A, B, C, G, and F, will be containing value 3.
Mhm.
Now here, an integer object is created with the value of 3, and all those 3 or 4 or 5 or even more different variables are assigned to the same memory location. You can also assign multiple objects to multiple variables. And this can be like here. So that means A, B, and C is assigned to 7, 8, and George. So if we were to print out this one, A will be containing the value of 7, B will be containing the value of 8, C will be containing the value of George. Now, now Python is completely object-oriented, okay, and not statically typed. You do not need to declare any variable before you type it or before you use it. Okay? Every variable in Python is an object. That means you can just go ahead and use it. You don't necessarily have to declare it way in advance because Python will automatically be able to assign that value or the value to the variable. So Python supports two types of numbers. We have the integer, which we all know, and we also have a floating point. And it also supports what we call complex numbers, which pretty much we use a lot of this in like in science, in physics, and also in very high level mathematical calculations. So for the sake of this class, we will just be mentioning these two, integer and float, and maybe just a little bit of complex numbers just to know what the difference is. Now, if you were to declare, let's say 7, this will be an integer. We say this is an integer. Therefore, we assign it to my integer, which is a variable. And then we simply come and say print. So we call the print function, and then we pass an argument, which originally was here as a variable. So the print statement here will go look in that memory location with a variable name my integer and basically tell us who the occupier is. And in this case, the occupier is 7. Okay. If we were to do the same with a float, we have to put, like, in this case, we can put 7.0, or in this case, we can put 9. So if we did my float, we assign 7.0, then we try to print that memory location. We get my float, and then we will be able to get what that content is. In this case, it will be showing us what's the occupier of that particular memory location. But remember, we use float here, which is a type. Type in the sense that we try to tell it, hey, give us the type of this memory location. So we will be able to get the type, and in this case, the type will be 7.0 as an output. So a complex number, on the other hand, represents, let's say, x plus yi. Now, Python converts the real numbers x and y into complex numbers using the function complex. The real part can be accessed using a function real. and the imaginary part can be represented by the function image. Okay. Python can handle complex numbers and its associated functions using the file cmag. Now, that's complex numbers have their use in many applications related to mathematics, engineering, physics, and those high-end calculations we might be able to do, like very high-end research. So Python provides useful tools to handle manipulate those numbers. Okay. So this topic for complex numbers in Python is currently beyond the scope of our coverage. So we just mentioned in the slide, we don't have to worry about it, but at a certain point, when we get really deep into Python, then we'll bring it back, and then we'll be able to see practical way of applying it. Okay. So our next topic is going to be strings. Now, remember strings, just like your name, Irene, my name, George, and any other sentence, so long as we can enclose them in a quote or in a double quote, then that will be a string in Python. So strings variable in Python are defined either with a single quote or a double quote. So we can say here, hello world. These are single quotes. And then we take the word hello world, and then we actually save it in the my string. Then we come here and say, now we would like to go ahead and print the contents of that memory location, which is my string. So when we do that, it will be able to print the word hello world without printing the quotes. The quotes are just there to let Python know that these are actually a string. So when you print out, it will only print the contents but not the quotes. Alternatively, we can also use double quotes for actually doing the same thing. Okay, so either double quote or single quote will do. Python doesn't care. There are cases whereby you will be able to distinguish them, and I'll show you here shortly. Now, the difference between the two is that using a double quote makes it easy to include apostrophes within the sentence, like this one. Don't worry about apostrophes. If you did this with single quotes, the system will not be able to recognize what that is. So you have to do that with double quotes at the end, but you can do this in single quotes. You can also do it with single quotes, but you have to escape the single quote using this backslash. So backslash will be able to tell Python to ignore this single quote, but just look at this, which are visible to it. Okay, so we can do this without necessarily that, but we cannot do this single quotes with that single quote and that single quote and expect to get results. So in this example, if you were to declare a string variable with a single quote, then you will need to escape with a backslash. Okay.
I need to plug my battery.
Well, go ahead, I'll wait.
Okay. All right.
Hello, Nancy. How are you? Yes. Okay. I wanted to use it, and it was telling me somebody had a meeting going on, so I was wondering. Oh, okay. Yeah. Okay. That's okay. I'll call you. Let me. I'm in another meeting. Yeah. All right.
Okay.
Sorry about
Sorry,
that. Mm-hmm.
I
You
got
got
disconnected.
okay. You got it sorted out.
Yeah, I plugged it back.
Oh, cool. No problem. All right. So, like we were talking, say you can use double quotes or single quotes, but if you were to mix them, okay, there are cases whereby you can mix them like here, so here, but you have to escape this one so it does not conflict. In this case, if you were to use single quote all through with this one in the middle, then you have to escape that so Python will not be able to throw errors. Now, okay, if you were to declare a string variable with a single quote, then you will need that. Okay? They don't like whatever we do with the backslash. Otherwise, without the escape character, we shall receive an error message in code. There are additional variations on defining strings that make it easier to include things such as carriage return, like when you press an enter key or a backslash, and Unicode characters. But those are beyond the scope of this class right now. You can read it somewhere here to get to know more. Okay. Now, simple operators in Python can be executed on numbers and also on strings. You say we can assign number 1 to variable moja, number 2 to variable mbili, and then we say we declare a new variable, we call it tatu. But this time around, we take moja plus mbili to give us the result of what tatu is. And then we come here and simply print it. If we did the printout here, we expect that printout to contain the addition of 1 plus 2, which is actually going to be the result is 3. Okay. Now we
The
can
class
also,
will actually do the math.
say again.
The moja plus mbili, it will actually, the plus is just like a regular addition.
That's right. So let's go ahead and run it here. You see how it works. Okay. Let me bring it up here. So if we were to do moja, and then we try to print out what is in moja, we just do that. Okay. Okay, and then we say mbili, we print out what is in mbili. So those are just variables, but I'm using the Swahili words as a variable name. Then we can go ahead and say what is in tatu. That's going to be, if we were to print out this addition here, let's see what comes. So we have number 1, which is being printed here, moja. We have number 2, which has been printed there as Billy.
Mhm.
And then we have the total of 1 and 2, which is now printed as 3. So cases whereby maybe a time will reach whereby we just need to be able to say what is in title. We can do that. And then we run it again. Okay. And then you can say what is in Billy. Okay. Let's say Billy here. Okay. That's not right. It's in Billy. That messes it up. So, print Billy. Okay. Measure Billy. That's in Billy here. Okay. Then we send Billy. Then we come here. What is in title? So we can say what is in title. Remember, we can use single or double quotes. So I use double, but I can also use single. So here we come and send it. Then this
You already put Mbili up there.
bill is already up there. So this should be
That.
title, which is here already. So we don't need it.
Mhm.
We don't need that because it's already down there. We don't need this. That's already up there. Now we just say this is good. What is in Moja? We can say what is in Moja here. Let's use single quote, comma, and then we say what is in Moja. If we print, then you'll see it will give us description. So we print it out and say here. This is how you make, let's say you make your work or your code more interactive and self-documented. So even if you come back later, you'll be able to know exactly what you're trying to do here. Okay. So you see, you can actually use single quotes the same way we can use double quotes, and it does not make any difference in this case. Now, having said that, we can go back here and run this example. Okay. We see how it works for us. Okay, so we come here. Let's say run that. So this one, we just comment it out, and then whatever the contents of this one will be stored in this. And then we print out that content here. So let's go print it. It tells us what that was. Now there are cases whereby you can, let's say you made a mistake, you put those single quotes. Now Python will maybe give you an error because in this case, we have single quotes throughout and this one in the middle. If we were to run this, we have an error, a valid sentence. So in such case, we always want to escape that. So if you did the escape that way, you miss it. So you want to do the escape first and then the apostrophe. So if you were to run this, then you should be able to get yeah. So the escape is good, but it has to be before the apostrophe. Sometimes myself, I forget where I need to put it, but sometimes I have to be able to remember by doing the code and then run it. Okay. So that's the way that is going to be treated, and that's the way we are going to be able to get the variables assigned. Now, if you were to say habari equals to habari, habari in this case, we know it's a Swahili word for jambo or how are you, okay? And then we say zeni. And then we come here and put a comment, and then we concat these two words, habari plus zenu will be treated as two strings and then combined by a plus sign, which is a concat in Python. So let's see how that would work. We'll say here, bring it here, and then we test it. So we say habari, and then we say zenu, and then we combine the two as if we are adding them. Now the middle, the apostrophe we are using here in the middle is to help separate the two words. So if we were to do this zenu and habari, we basically concat them, but we separate the two wordings. And then we take both two and store them in the variable jambo. Okay. So you always want to make sure that your case is sensitive. If it's lowercase, let it be lowercase. If it's uppercase, let it be uppercase. Like I just did the changes here. Okay. So if we were to say save the two, okay, in the Zoom, I'm sorry, in the Jambo, then we go ahead and print it. At this point, we say habari is not defined. So we know we need to make that change because of the case sensitivity. Because we did change here, but we never changed that. So by leaving some underscore, some small letters and some capital letters, it's not going to help unless it's all consistent, because Python is case sensitive. So we have to be aware of that. So now that we change and then we run it, we are able to see that Jambo will contain the two words habari and zeni, and then separated by this middle two quotes. And then now we have a very neat printout. The same thing can be like this. Let's say coffee. We run this. Then we say, go ahead and say first name. We say F name, and then say last name. Okay. And then we say here. Okay. And then we say here, Irene. Now, if you run this, you get an error because this and this are declared, but this now is not declared. So let's run and see. Okay. Let's run here. For some reason, this is not error because this one and this one are actually in this one, as much as they are not declared. So if we go here and say this is Irene, and then let's try run it again. Now we have an error because we declared it, but now this is not declared. So instead of putting the value here, we need to put the variable. Let's put this variable. And then this one, we put as the last name variable. Okay. 1 second here, Irene. Somebody asked me. Okay, so we say now the full name will be the combination of first and last name. And then we go ahead and change that full name here. So if we were to run this, it will give us Irene Otero. So let's run that. And that's how we do concatenation. Now in Python, you see we can use the plus sign for math, like addition. And then we use the same plus sign in concatenating strings. Now, when we do that, we call it operator overloading in Python, and that will come up in a few chapters from today. Okay. So we've just seen how we can concat strings and how we can also use the same operator to add the numbers. So we go back here, and then we say the same explanation of what happened. So line 1, we assign a variable moja. Line 2, we assign a variable mbili. Okay. On line 3, we do the addition of line 1 and line 2. And then we go ahead and spit out what is saved in the variable tatu. Okay. So number 4 here, line 4, we'll be able to print the results, which is number 3. Okay. So on line 5, as you can see here, we did habari. We assign habari to habari, and then zenu to zenu, and then we concat the two. Then we print out the variable which is storing both two values of habari and zenu. So we can use again doubles or single quotes in the strings. It really does not matter, but there are cases whereby sometimes you need to escape certain quote if you're using all single quotes, like we did here. In number 7, this is just a comment. So telling us what we need to do. Okay. Now in Python programming, assignments can be done on more than one variable simultaneously, okay, on the same line, like here. So if we were to do that, let's go ahead and run and see how that runs. You can come here and say variable A, variable B, variable C, and variable D will correspond to 3, 4, 5, and 6. You don't want to miss anything. They all have to be one-on-one relationship. So 3 will be assigned to A, 4 will be assigned to B, 5 will be assigned to C, 6 will be assigned to D. If we were to print out that, then we'll be able to get all this printed out here. So let's go ahead and run that. As you can see, that's going to be exactly correct. Now, what if we made a mistake? We say E, but we never assigned E to anything. So we run it, we get an error. Not enough values to unpack. That means we give 5 values, but we give 5 variables, but we only supply 4 values. So it's telling us not enough values to unpack. 5 are expected. We only got 4. So let's say we give them 1 more. Okay. So here we know we'll be able to run it, no problem. So you can run it, but again, you have to make sure that you include in the print statement for it to appear there. So we ran correctly because all the values and the variables are corresponding to each other. But when we print, we only print what we had before, but we forgot to print E. That did not cause any problem. We were able to come with what we gave it. That's the garbage in, garbage out. But now that we added 4, we should be able to, we added the 4th one, we should be able to give it a 7, we should be able to give it here so that we can get it down. So look, we got it. Now what if we put more values and we did not remember to put additional variables here? Let's see what happens. Should be an error. Okay, too many values to unpack, we expect 5. But we are only given, we are given 5 here, but we have 6 here. So that's unexpected. Okay, that's how we see how those errors work. Okay, so we come here, and then we say that example, we mix the operators between numbers and strings. We cannot do that. We cannot support, let's say, number 1, we give it to 1, number 2, we give it to 2, and then we say hello, we give it to hello, and then we expect to combine integer and strings to print them out. This will not work for us. It will give us an error. So if we try that, okay. So number 1 will be number 1, number 2 will be number 2 variable, and then the hello will be in the hello variable. And then we try to print this, and then print that, and then we try to concat that. So if we try that, we cannot combine or we cannot mix the integer and strings, or even the floats together with the strings, and then we try to print it. It will give us an error. So let's see what the error is. Unsupported operand, integer and string. So that cannot work here. There are cases whereby you will have to go through the process of just making sure that maybe you want to change that as an integer. Maybe if you do that, it might work for you. So it's going to be able to look at that as a string. Let's see if that can work. Still not able to work. So we have to make sure this has to be changed here, maybe. So if we were to do integer here, you always have to make sure they're all of the same type. So we assign that to that, and then we try to print it out. This is just a test. Let's see if that can work. I run it. Can't assign to function call. Okay, so we know this is not going to work. Okay, what if we did here? So we know it's not going to work. So you have to manipulate it somehow if you really have to do that. So we cannot mix types here. You only can do that if you change this one to the same type like this one. So you have to maybe assign something else, change it, and then bring it back and use it in order for it to be able to be seen. Okay. All right, so the target of this exercise is to create a string, which is like this one, an integer, which is like that, and a float. Maybe we can put a float here. Okay. Now the string should be named myString. So this is an exercise and should contain the word hello. The float point number should be named myFloat. Okay. And should contain the number 10.0. And the integer should be named myInt and should contain the number 20. Now, as you can see, we can do that here. So Change this code, put none, put C, put my integer none, and then this is a comment. And then if my none, which is now been assigned to my string, is here. So none, we're saying compare none to hello, which is a string. And then print string, then this is symbol for a string, and then string here. So let's see what this will do. If we do that, okay, we assign my float to 10. We try to print my float, which is now the F, my float. If this is an integer, we assign integer 20. We try to print it here. Okay. Now let's see how we can run this in a real life scenario. So we bring it here. So we assign the word my string to none. Assign the word none to my integer. If my string is equals the word hello, if the word hello is in my string, then we print string and the content of that. So let's see what happens here. We expect an indent, which is just this one. And we run it again. And now C is not defined. As you can tell, C is just hanging. We don't know what is in C. Okay, so that's the error we get. Now, what if we don't need, assuming that we don't need that? Then let's go ahead and run it again. Now we know the none is in my string. The none again is in my integer. And then we try to say, if my string contains the word hello, which in this case is not true. Therefore, if it's true, then we get a printout. Since it's not true, we actually don't get anything back. Now, if we change this one here to hello, and then we run it again, we should be able to get something. Because now we know my string is actually containing hello, and therefore, this has to be true. So let's go ahead and try that. So now we are able to meet the condition. We took the string hello string, we took the word hello, we put it in the variable my string. Then, of course, none we put in the variable my integer. Then we say if the contents of my string is actually hello, then go ahead and print out what is in my string. So we are able to do that.
Okay, so the percentage sign and S is plus, or what does?
This one is a placeholder telling you that this is a string. If you see F, it's going to be percentage F telling it's a float.
Okay.
If it's a D, like a percentage D, it's going to be an integer.
Okay.
Okay. So come back, say, okay, so far so good. Now this is another example. Let's go ahead and run this separately from the other one. Machine run this. Okay. So we come back here. Then we run that code. So we say if this instance, my float, is a float, and my float equals to 10. So we basically take this 10 float number, we keep it in my float. Okay, and then we say if my float is my float, and that my float is actually 10, then print my float here. So as you can see, this is F now, placeholder for float. Okay, if the instance, my integer is integer, and my integer is actually 20, then print the integer. And the placeholder for integer is E. So we try print it here. So let's go ahead and see if this can work. Get an error, expected indent, so we can indent it here. Python is very sensitive, and that's the way it keeps its block of code. So we have to indent. Maybe this will be also another issue. We have to indent it, but let's see what happens. So we have to indent it too. Then we run it again. So we have to say this has to be defined. Remember, it was defined somewhere, not here yet. So my float, let me see if I define it in the code. My float has to be defined. So we go back here, define it. Let's go ahead and define this one. Definition. Okay, we assign float 10 to my float. So that's a definition. And then if we run it, we also have to assign this one because it will complain. So let's go ahead and run it before and then see what this does. So it's telling us my float is not defined. Okay.
You have two equal to.
That's right. You got it now. Should be one, right? Okay. Right. So you see, we define my float is 10. We print it out. Okay. My integer, let's go ahead and define my integer here. That was really good catch, Irene. Assignment and the double quote is comparison. I mean the double equal sign is comparison. So if we try here, we should be able to get 10, and hopefully we are going to get 20 there. So try that. Okay. So we know before you use it, you probably need to define it. Okay. So that's what exactly we did. So this should be able to work for us. So we come back. So we have the standard data types. Okay. Now the data stored in memory can be of many types. For example, a person's age is stored as a numeric value, and his or her address is stored as an alphanumeric character. So my age in the system is going to be numeric. My address is going to be alpha and numerals, like alphabet A, B, C to Z, and the numerals will be from 0 to 9. Python has various standard data types that are used to define the operations possible on them and the storage method for each of them. Remember we spoke about the primitive data
Yeah.
type? Yes. So these are now coming back again. So numbers, strings, those fall under, so numbers will be float and decimals, okay? They fall under the numbers. And then we have the string, which is now numbers and strings fall under the primitive data types. So Python has 5 standard data types. Now, the non-primitive will be the list, the tuple, and the dictionary. So these 3 are non-primitive, and these 2 are primitive. Python numbers or number data types store numerical values. Number objects are created when you assign a value to them. For example, you can assign number 2 to value 1, number 3 to value 2. You can also delete the references for number object by using the delete statement. The syntax is as follows. Okay, you can delete a value, let's say that value 1. So we delete this from what would be this as in a list. So you can also delete the reference of a number object. You can delete number 2 from inside that list by using the delete or del statement. You can delete a single object, or you can delete multiple objects by using the del statement as below. So you can delete, say, delete value 1, or you can delete value 2, value 3. Okay. Python supports 4 different numerical types. Okay. We have the integer, we have the long. Now, when you say integer, integer will be 0 to 9 up to certain length. But we have the long. Long will be like very long. We're talking like billions, for example. Okay, so long integers, they can also be represented in octal or hexadecimal. Okay, octal or hexadecimal will be something like, let me show you.
X plus X, Y, I, or something like that.
Yeah, something like that. Yeah, so those in Python can be very special, and therefore they are long, they're falling under the long. So octal, something like this could be binary, right? So if we octal to binary now, if we have, say, say we have, let me look for a good example. 56 to the base of 8, that's octal. Or 643 to base 8, that's octal. Okay, those are octal numbers, as you can see here. Okay, now hexadecimal will be like very special now. If we have hexadecimal notation, you can take, let me see here. You can take A to F, those are falling under the hexadecimal. So we assign them certain value. Now A, B, D could mean something in hexadecimal. So hexadecimal numbers in Python, we have to declare them as long. Okay. So we come back here and say, Float numbers are anything with a decimal point, like 1.0, 2.0, 2.2.2, maybe 2.2 or 3.14. Those are float point real numbers. Complex numbers, like we talked about, those are like 1 plus j. This is very special. Now, here are some examples of numbers. Now, if you were to do something like this will fall under long. These are integers. Okay? Anything 0.0 or 15.2, those are falling under float. Some of them could be 3.2, 0.3, exponential, like 8, 18. So that's to the raised to the power of, like, they are very long. These are floats. And then something complex would be like 3.14j or 45.j. These are very special. Now, Python allows you to use lowercase in long, but it is not recommended that you use only an uppercase to avoid confusion with the number. So Python displays long integers with an uppercase. A complex number, for example, consists of an unordered pair of real float point numbers denoted by x plus y and then j. So when Python sees that, it will know this is a complex number, where x and y are the real numbers, and j, in this case, okay, it's an imaginary unit. Those are very deep math and science and physics. So we'll talk about them, but not immediately now. Now, Python strings, which is also, remember, they are primitive data type, are identified as a continuous or contiguous set of characters. Your name, my name, those are strings. They're representing the quotation marks. Python allows for either pairs of a single or double quotes. Subset of string can be taken using the slice operator. So we can use this square bracket as a slice of operator to help us basically to be able to, let's say, we can have, let me show you. You see how we did this? We can slice this into units, and then we just delete what we want. Now, if you put 2 here, delete value 2, it's going to actually go look for that value 2, delete it. So we use the slice operator, which in this case will be the square bracket. But in the square bracket there are items which we are going to subject the deletion or the operation to. So Python allows for either pairs of single or double quotes. Subsets of strings can be taken using the slice operator. Okay. This one, or we just use this one, which is just square bracket. Now this will index starting at 0 in the beginning of the string and working their way from negative on the right far end. Remember, if we put -1, we're going to get the last item on the far right hand. If it's like hello world, -1 will be that apostrophe. But if it's +1, then here we start from 0. Therefore, +1 will be E. Now the plus sign is the string concat. We use that for concat, like for adding strings. Like we added your 2 names to 1. Or we added hello, white, or habari, zen. Okay. Now this one is for concat operator, and the star is the repetition operator. If we did that, let me show it here. We can do this here. We take this number, we put it in the string. Okay. Let's go ahead and print the string. If we run that, we expect it to show us that number right there. Okay. Now remember 0, 1, 2, 3. But if we start from the right, start from -1, -2, -3, all the way. Okay. Now, what I'm trying to show you here is to be able to see how the star will work. So we come back. Say we have 2, string 1, and then string 2. And then now we come and say, we print string 1 plus, and then string 2. If you are to print this one, it will give us the same answer.
Do we need to put a plus before string 2?
Right, thank you. Okay. See how good you're doing, huh? Now here we can create that space. Now we have it, okay? So, what if we wanted to multiply this more times? Like we want 3 of this. Now let's go ahead and see how that works. Okay. They say we can use the plus operator. If you do the multiplication, it will multiply. I remember I showed you this before. You can multiply number of times, and it will be like several of those. Remember that?
Yeah.
Okay. So we can do the multiplication to multiply number of times the same string. Okay. Now, if we wanted to use, let's say, we want to print a complete string, this one we did. And then we just want to print the first occurrence of H. Please print the first character of the string. So we are slicing it. And this one will print the character starting from the third one. So we go 0, 1, 2. Okay, so we start printing from the third one. So this will print from the third one and it will count 5. So 1, 2, 3, 4, 5. Remains a W. Okay. So let's go ahead and run this step by step so you see. Okay. Okay, here we have hello world. We just want to go here and then print the whole hello world. After that, then we go ahead and say we want to print only the first instance of the hello world, which is 0, which is H. And then we here come and say print from number 2, but limit to 5 characters. So let's see what this one brings. Okay. So this will print the whole thing. This will only get the first one. And this will get all the comma 2, take 5 rows. So if we state 0, 1, and then 2, 3, 4, 5 space. If we put, let's say 5, something like that, then let's see what this will do. If you grab that V. V, so it starts with 0. And then here we start with 2, which is 0, 1, and then 2, 3, then that. If we change this one to 6, let's see what that. Okay, so text it.
Yeah, I think I got confused that one too in one of the ones in the quiz, because when it's 2 to 5, I was including 5.
Yeah.
And I guess you're not supposed to include it.
No, it starts from number 2, prints a character starting from this, the third one, to the 5th one. Now we change that one, it's going to be from the third one to the 6th one. So if you had, say, hello, this one here, we start from third one. This is 0, 1, 2. The third one is number 2 here, okay? This number 2, 3, 4, 5. So that's, just remember it starts with 0, but that's an index count. But the values are actually, this one is second. That is third. That is fourth. And the space here is the 5th one. That's why we come back to this one. If we did 6, 1, then we most likely capture the W. So it will come and say, hey, we are going to go and get 0, don't want that. 1, don't want that. We start with 3, 4, 5, and then 6. If we say 7 here, then it will take the W now. Look. So it goes to the next one. So this, like you said, is a little confusing, but it's something we have to make sure we remember, because it come back and bite us again. Okay. So we go here, and now we can print strings starting from the third one. That means start from the third one all the way. You don't have to limit it. Okay. So let's go ahead and copy this. So we come back here, we basically paste it there. Then we remove the numbers. Now we go ahead and put a space. So this one we know what. Now this one is going to tell us, hey, do the same thing like this one, but now we are not going to go ahead and limit anything. Just take everything all the way and print it out. So this will be LLO space wild. That's what we expect from here. And then this will tell us, take the same thing, but multiply it times 2. Okay, and then this will say, take the same thing, which is string hello world, and then concat with a test case. Just put the word test case at the end. So let's see how that works. So what I'm going to do here, not to mess with what we have before, I'll go ahead and put this separate in its own cell. So we go back, include them here. When we run this, let's see. It takes everything from L, LO all the way, and this one actually takes the same thing here we had, but multiply by 2. And then this one basically concats it. This one concats it.
So we can just add test case, even though we didn't have any variable assigned to test case.
Yeah, now remember, we don't have to have a variable because this is in itself a string. So it's like a constant. You don't have to put a variable for it. You just concat it. So if this was not enclosed in any quote, then it's going to be a problem. That means we have therefore to assign it to a variable. But if it's not in any, if it's in any quote, then you don't have to worry. You just basically bring it and just add it. So here we can say, let's say habari. If it's good. Now you can do this. This is allowed. Look what it does. It just adds it. But if you really want to use it, something different, like other than that, then this now has to be assigned. If you run this, it's going to be an error, invalid. Okay, so this has to be a string declared in quotes. This, just as multiplication, you can multiply 3 times. Is that clear? Together? Erin?
Yeah, makes sense. Yeah.
All right, so here, these are the okay. Now, so far, so good. We know they are primitives, like we did a lot of primitives, and also non-primitives. Now we are going to go back into lists. Now, this time around, we are going to do a little bit more practical on the list. Remember, the other one was just an overview. So lists are the most versatile of Python's compound data types. A list contains items separated by commas and enclosed within brackets. Now, the good thing with lists, they could be heterogeneous. They can be numbers combined with strings, floats, integers, or all something which you cannot do with arrays. Arrays, it has to be homogeneous. To some extent, lists are similar to arrays, like arrays in C. One difference between them is that all the items belonging to a list can be of different data types, heterogeneous. Lists can contain any type of variable, and they can contain as many variables as you wish. Lists can also be iterated over in a very simple manner. Like you can print it over and over, or you can go access it over in that memory location without any issue. Now the values stored in a list can be accessed using the slice operator like we just did. So we did this, and we also did that. With index starting at 0 in the beginning of the list and working their way to the end. When you start from the right first side, it starts with -1. From the left side, we start with 0. The plus sign is the list concat operator. It means we can add those two. Okay. And the asterisk is the repetition operator like this. So if we say list, put A, B, C, D, number 3, and then 886, and then 3.1, 3.25, then the string, and then that. So we know this one is a float, this is a string, this is a float, this is an integer, and this is alphanumeric string. And then we can go assign those to a list. Tiny list, it's going to be like 1, 1, 2, 3, and that's the name. Okay. You can do that. In array, you cannot mix them up. It has to be one homogeneous data type. Okay. So here we can say print a list. It's going to go ahead and print everything in that list because it stored them in a variable name known as list. If we did, let's say print 0 of that list, it will take the first. It will not, in this case, it will not only take A, it will look at this as one unit. Therefore, it's going to count this as 0, count this as 1, count this as 2, 3, and then 4. So in this case, it will print first element of the list. In this case, it will get the second element, but go up to 3. So the second here, third, and then this one. Print element starting from third element. And this one is tiny. It will print whatever we have here times 2. So let's go ahead and run this. See what it does. Okay. So let's go back and get the rest. I'm gonna go ahead and split them up into different cells. Come back here, paste it, then remove this one, remove that one, remove this one. What I would like to do, I'm gonna go ahead and separate that. We run the first one, you'll be able to see what it does here. And then we do the second one. So this will complete the list as shown, this one. So we run this one first. Now we know everything is being stored in the list and tiny list. Then we run this one. Now we see these are elements. These are 5 different elements. Okay. Then we go to the next one. Here, we're going to go ahead and just run this one. But remember, we kept everything in the list, so it will go ahead and grab only the first one. So let's go ahead and see what does that do. See, this element, block of element, is treated as at position 0. Okay. Okay. Now let's go ahead and run the next one. Okay. This one we pick whatever is in here and count 3 more and then stop and then print them out. So let's see. Okay. So this is 0, this is 1, 2. Okay. So it comes from 1 and limit to the third element. So this one means third element. It does not mean the position A. So if this is 0, this is 1, this is 2. So when we put this one, it will say start with the element 1, but take the third position. Element 1, take the third position. Just like we did here. This one will take everything from element 2. This one will take element 2 and then 7th position. Okay. Here, okay. Element 2 and get 7th position. Okay. This one will take everything up there. This one you get element sorry, element 2, and third position. Okay. Okay. So let's go back here and see what the next one will do. So this one will take second element all the way to the end. So if you start from this one, element 2, all the way to the end. Okay. This is 0, this is 1, this is 2. So start from 2 all the way to the end. Let's see what that is. Okay. You can see, start from element 3 all the way to the end. Initial of that is number 2 to the end. And then let's see what the last one does. Okay. This print 2 lists twice, tiny list twice. Okay, so it takes whatever is here, okay, and then multiply by 2. Okay, so let's see what does that do. As you can see, we multiply by 2. Okay, so that's how we get to do lists. Very tricky, but sometimes practice will make it perfect for us. Now we can even concat the two, combine them together. How do we do that? Come back here and run that code. It will take the total of whatever we have, top and bottom, and combine them too. Okay, so we come here. Now we have everything all in one. Okay. Which email would you like it to go to?
Just do the Gmail one. MAY.
MAY.
Yeah. MOG. I might save it by name. I guess it should. Good. See, I read that it's not. You don't have the email?
No, I have the email. I'll send it to you. I thought maybe it's probably here somewhere, just not populating it. But I'll send it to you. Okay, so we can concat those two. So come back here. Whatever we did is all here. Okay. And then another example.
Why is it on the call up? Go back.
Okay.
So when you have print lists and then you added a tiny list, why is list blue?
Now the list here is blue because list, you remember, actually we are not even supposed to use the word list because list is blue because it's a reserved word in Python.
Okay.
When we use it here, I would rather not use a list. I would rather not use a variable which is already a reserved
List.
word.
Yeah. Okay. Okay.
Yeah. So here we go. And we can do more. When you declare my list as blank, that means you initialize it. And then you can append a number to it. You can append the second number to it, append the third number to it. And then you print list prints 1. Okay. And then this one will print position 2. Then print this one at prints 3. So we have 1, 2, 3. So this one, append 1, append 2, append 3, and then print this one. So let's go ahead and run this one, please. that. Go ahead and append. First of all, we initialize the list. Initialize, that means it's a memory location. We clear everything which was originally in there. And then it's almost like a blank plate. And then we append the first number to that blank plate. Append second number to the same blank plate. Append third number to the same blank plate. And then print the first number. So let's go here and see. Okay, let me do this. I would like you to see step by step. So let's see step by step here. Let's print the content of that my list. We have it as a blank slate. Okay, and then let's go do. Let's go do this one, and then print. Print my list. Okay. Run that. Now you see we appended one, right? It was here. Now it has something. Okay. Now we go to the next one. Append another one. Okay. So we print. Okay. Print my list. Now we have the next one. Okay. And then we append another one. Okay. So we do this. We see what that does. We append. Now we print that out. Print my list. Okay. So we run it. See what that. This is print. Okay. So we've already appended. We probably appended twice here because I ran it twice. Actually, 3 times. So if I do it again, you'll see it keeps on adding, like, you know how the append works, right? The way we did it before. Each time we append it. We can also remove them by popping them out. So we did appending, and then the last one here will be to pop it out. I mean to print the first one. So let's print the first one in the list. That's going to be this one, 0. If we run that, it's going to give us the first instance of that list. Okay, so come back. Now we printed that out and we saw exactly what happened. If you wanted to get everything out, you have to declare loop, which we will also do. I'll introduce to loops. So you step over, and actually you step over an array or step over a list to print it out. So this one, we can go back here and declare a for loop. I'll introduce it to the loop. So right now, this is just for illustration. So a loop here will be able to tell us, hey, go in this X, which is now a new value, now a new variable. In that list, look in the memory location my list and assign them all to X. Okay, assign everything you have in that list, which was here, all this. Okay, we are going to assign them to X. And then whatever we assign to X, which means we know it's in my list, but we don't want to interfere with it. So go ahead and declare a new variable, call it X. And whatever is in my list is going to be now moved to X temporarily. And then let's go ahead and display the content of X. So here, if we say print, look what it's going to do. It's going to print everything in that memory location and spit it out. If we did anything like name, whatever we did, like all this mixed up stuff, you can spit them out in a loop using the for loop. You just have to declare for loop for the new variable. That new variable could be anything. Like here, we can say, hey, I would like to use my name. So we say Irene. Okay. And then here, you can use Irene. If we do that, it's still going to work. Okay. So X, it's okay, but it does not describe what eternity is. So you probably want to be very descriptive in your program. Okay, so we come back. Okay. Now, the output we just saw is as a result of our declaration of the loop. Loops are a big deal. So it's going to be spending a lot of time in loops before we go into functions. So when you try to access an index which does not exist in the program, you generate an exception error. So if you try to access something which does not exist, it will definitely bring a problem. So we have to declare that existence first. So like in my list here, we know it's 1, 2, 3. You can print, we print 10, but we know there are only 3. It's going to be a problem. So let's see here. Let's see what this does. That's going to be a problem though, but let's see what it does. Okay, come here. Okay, we try to say, hey, we are going to assign 1, 2, 3 to my list, and now we want it to print 10. 10 from where? It's not there. Let's see what that does. That's a problem. It's out of range. But what if we say we want to print 2? This will probably work. What if we say we want to print 3? That is going to be can you tell me what's going to happen?
It's out of range.
Yes, because remember it starts with 0.
0, 1, 2.
This will be out of range too. So that's how we cannot bring it if it's not there. Basically. So we come here, and those are the things we just got. Now in the exercise, you will need to add numbers and strings to the correct list using the append statement or append method or function. You must add the number 1, 2, and 3 to the numbers list and the words hello and world to the strings file. You will also have to fill in the variable second name with the second name in the list using a bracket. Note that the index is 0 based. Starts from 0. So if you want to access the second item in the list, its index will be 1. The third item is index 2. Fourth item is index 3. Fifth item is index 4, all the way up. So here, what we basically do, we come and initialize the memory. We clean it up, we clean the slate. Okay. And then we declare another one, strings. We clean the slate. And then We come here and declare third variable. Now we put the name John, Eric, and Jessica in there. And then we write your code here. Now, second name is none. This code should print out the field arrays and the second name in the list Eric. We'll print the numbers, okay? Then print the strings. And then print the second name of the list. This is a string, second name, okay? So let's go ahead and try this code. Okay, so we know we want to do something here. So clear the screen or clear the memory, initialize. Okay, and then we do another clear the memory string, we initialize. Okay, so those are two. And then we go ahead and do the next. Now here the name. So we save every name, John, Eric, and Jessica into names. Okay, and then we go to the next one. Now we go ahead and write second here. None into second name. Okay. Go back here. So that's just a comment. This code should print out the field arrays, second name in the list, in the name list area. So here we are going to print the first one. So we clear that. And do this. Make sure you get it. So let's go ahead and see what happens in numbers. Remember the numbers was cleared. So if there anything here, it's blank. Okay. Then let's see what is in the next code. Strings. Is there anything in the strings? Most likely it's going to be blank. We just cleared, but we never assigned anything to it. Okay. It's also blank. Okay. So that array and the other array, those are blank. Now let's see what is in the last one. Now print, we're printing the second name on the list is second name. Did we assign any second name to anything? Yes. Assigned to none. Okay. So let's see what happens here. Okay. Second name is actually none. Because now, remember, the name is blank. And then we went ahead and assigned it. No, sorry. The second name was assigned the word none. If we did here, change it to Eric, and then we run it, it's going to be assigned Eric. Okay. We can assign it Eric. Now, if you come here, you can now print it. So the word none, as you can tell here, does not need to have a quote because it's specially signed in Python. It means completely blank. You can use it. Okay. So here we are able to come and say, hey, whatever that number was, you can go and say, no, it's none. Okay. So that's how we do it in this respect. So you come, you get the output. If we change certain things, you get the output the way it's supposed to be. But from the code we did, these are blank. Now, when we try to print them, we're going to print blank. But if we assign, let's say we assigned this to the word, let's say we assign that, we change this one to names. Let's go back and show, I'll show you. Let's go ahead and run this all together. We did that. If we assign numbers, strings, we basically initialize it. Now, the names we're going to assign to this one. I'm sorry, to this one, strings. So we say, instead of strings, we say names. Okay, and then here, we have to say names now. Okay, and then numbers, we don't have any numbers, so it's going to be blank for now. Okay, then here, we're going to assign the word, let's say, Irene. Name Irene. Okay. Now, if we run it, numbers will be blank, names will be blank, but now will be assigned with those three names. So let's go ahead and say Irene is over here. Okay, and then the second name will be now assigned the name Irene. And then when we print the names, it's going to print all the names, and then it's going to print this one again, but with specific name of Irene there. So let's go ahead and run them. Okay, so I need to do something different.
All the numbers.
Right, got it. Thank you. Okay, run again. Now we have, this is blank, this is John, Eric, Jessica, and Irene. The second name on the name list is Irene. So we got it. Okay. It's pretty easy, right? Very straightforward.
Yeah.
Yeah. So list in Python is lived, just like any other data type, but we happen to use a lot of it, especially in declarations. You can put a number of things in there because if you take floats, strings, integers, text, you can even take some of the non-primitive data types into itself. So it's mutable. That means it's editable dynamically. And when we declare it with square brackets.
Mm-hmm.
On the other hand, a tuple is another sequence of data type that is similar to the list. A tuple, when we declare, we use the parentheses like a bracket, normal bracket. But tuples are immutable. You cannot edit them dynamically in the program. A tuple consists of a number of values separated by commas, just like the list. But unlike list, however, tuples are enclosed in parentheses. A tuple is a data structure that has a specific number of sequence of elements. Specific in the sense that once it's in there, it's in there. You cannot change it. The only key difference is that tuples are immutable. Also, tuples use less space than lists in memory. Okay?
So you cannot append or anything.
You cannot. If you try to append, it's going to give you an error. Yeah, you can close, let's say, you know the bank account, you know the social security number, you know the name, you can put this in tuple because we don't intend to change it.
Okay.
But if it's something you intend to change, then remove the address. Oh, by the way, the date of birth probably was wrong. Now we need to change it. Tuples you cannot. Lists you can change. Also, tuples use less space. That means when they're constant, they're constant. Lists will always move around because it's expanding and sometimes it may shrink. You can use tuples when you want a list of constants. Like we know, pi is always 3.14. So you really want to save something like that in a tuple. It's not going to change. Let's say 1 meter is always 100 centimeters. You can keep that in a tuple. It's not going to change. It's a unit which is always going to be there. For example, 3 yards maybe make 1 meter. Could be wrong, but something like that, you're not going to change it. 4 quarters make $1. That's not going to change. You can keep that in a tuple. So you can create a new tuple with the same name and modify it in some way, but you cannot modify an existing tuple.
Okay. Makes sense.
Lists are mutable, tuples are immutable. It means that you can change the list, but you cannot change the tuple. Now, tuple is a collection used to create complex lists in Python, in which you can embed one tuple with another. Okay. This embedding means you create hierarchies with tuples. A hierarchy could be something as simple as the directory listing of your hard drive. Like you have the files, you have the folders, and you have the individual different types of files. Or in an organization chart, you have the president, you have the CEO, maybe the CFO, then you have the vice presidents, then you have everybody else down, based on the departments. Okay? The idea is that you can create complex data structure using a tuple. Okay? So in this case, a tuple will be very good if you know something's not going to change anytime soon. But if it's something you keep on changing, you probably don't want to do that. The main difference between lists and tuples are lists are enclosed in square brackets, and their elements and size can be changed, while tuples are enclosed in parentheses and cannot be updated. Tuples can be thought of as read-only lists. Okay. Now, these are the examples here. Probably the same thing we did. But right now, as you can see, we can only print them out. We cannot change it. We cannot do an append here. If you do, let's say 1, 2, 3 come out, you try to append, it's going to give us an error. So it's written on stone. That's the way I would like to think of tuples. Okay, these are the examples here. So I will not go into this because we are running out of time. So our next session, I'll go deep into tuples before I go into dictionaries, just with examples. Okay, I'll open it up for questions. If you have any questions for me.
No, I'll just go back and rerun them and practice.
Yeah, practice will always be your friend. That way you get errors and then you can always correct them.
Okay.
So I'm gonna use mailmogza@gmail, right?
Yes, that's correct.
Let me go ahead and send you this as we did today in your Gmail. So you can also, when you receive them, just practice it, and they'll be able to work for you. So you can copy and paste your pattern. And this is a load bunch of stuff. Load bunch. Yeah. Okay, I'm gonna go ahead and see if I can send this to directly. So how do you feel generally? Do you think?
I mean, I'm getting it. It's things are starting to
make some sense, right? Yeah, practice. Practice will make it good for you. Yeah. Very soon it's gonna get really deep here. As soon as we're done with dictionaries, then we go into the details of doing some examples. Let's say create, I can say, go ahead and create a phone book, or we create an address in on your street, and then we keep them in a dictionary, and then go ahead and print them out. It's just like that, slowly. Okay?
Okay.
Well, if you don't have any other question for me, uh, I'll let you go because I know you're still on vacation.
Yeah.
I say you enjoy your vacation as much as you can. When you come back,
I'll
you
try.
need all the you'll be again on the stress of going to work.
Yes.
Yeah,
Yes. That's fine.
yeah.
Thank you.
Thank you. You say hi to the family.
All right. Same
Uh-huh.
to you. All right.
Mhm.